Dear students, let's derive the electric field at an axial point of a dipole. So இந்த டெரிவேஷனுக்கு டயக்ராம் வந்து ரொம்ப ரொம்ப இம்பார்ட்டண்ட். டயக்ராம் கரெக்டாக வரையணும். டைபோல் வரையும் போதே ப்ளஸ் கியூ சார்ஜ் வந்து லெஃப்ட் சைடு இருக்கணும், மைனஸ் கியூ சார்ஜ் வந்து ரைட் சைடு இருக்கணும். And the distance between these two, we know dipole is separated by 2a distance. And இன்னொரு முக்கியமான விஷயம், dipole momentோட direction. It is always from minus q to plus q. இதை ஞாபகம் வச்சுக்கணும். இப்போ நம்மளோட aim என்ன? At point P, which is at r distance from the origin. So origin is here, okay? It is at the center of the dipole. Origin is at the center of the dipole. So from r distance from the origin, what is the electric field here? This is what we are going to find out. So first, electric field due to plus q charge at point P என்னன்னு பார்த்தோம்னா, plus q charge na electric field will be always out of the positive charge. So this is the direction of electric field due to plus q charge. Okay, இதே மாதிரி electric field at point P due to minus q charge. Minus q charge na electric field will be towards the minus q charge. So this will be the direction of the electric field due to minus q charge. Now we have to find out the total electric field at point P. So the diagram correctly irundhuchna, you can write the mathematical expression clearly without any doubt. Ipo electric field due to minus q charge, first I will write, because it is along the positive x direction. So 1 by 4 pi epsilon naught minus q divided by, where is this point P? It is at point P, the distance between point P and minus q. The distance between point P and minus q is r plus a whole squared. And we are writing this expression in terms of the vector quantity. So we are going to write this in terms of the dipole moment vector. We define the dipole moment vector going towards the negative x direction. So it makes sense. Here you see the electric field due to minus q charge is always opposite to the direction of the dipole moment vector. Let this be equation 1. Now write the electric field vector due to plus q. So we can write this as 1 by 4 pi epsilon naught due to plus q, and plus q charge is the distance between plus q charge and the point P. This will be r minus a whole square. So once again, it is along the unit vector of dipole moment. So let this be equation 2. Now we have to find out the total electric field at point P. So we are going to write the total electric field at point P equals E plus Q plus E minus Q, which is equal to 1 by 4 pi epsilon naught plus Q is Q divided by R minus A whole squared. Since this is a plus quantity, positive quantity, we are writing it first, and then electric field due to the minus q charge. This will be q divided by r plus a whole square. So we can write everything here in the bracket, and then we can give the vector, because left hand side, right hand side, both we should have the vector notation. So now let us take the common terms out. Common quantities, so q divided by 4 pi epsilon naught out, and we can write this as 1 by r minus a whole squared minus 1 by r plus a whole squared. And we have unit vector here. So q divided by 4 pi epsilon naught. Let us simplify this. So we can cross multiply it and then expand it. R plus a whole squared minus r minus a whole squared divided by a plus b into a minus b is a squared minus b squared. So that's what we are going to write, r squared minus a squared whole squared in the denominator. Once again we have to write here, this is the electric field. So expand this terms in the bracket and then simplify it. So we are going to do that. Q divided by 4 pi epsilon naught r squared plus a squared plus 2ar, okay, and then minus r squared plus a squared minus 2ar divided by r squared minus a squared whole squared. Okay, and we have p vector, unit vector here. So if you see here, r squared, and it minus, this minus goes inside, this r squared also will go away, a squared and a squared also will become minus, so this will also go away, and if this minus goes here inside the bracket, it will become plus. So we can write this electric field E vector equals Q divided by 4 pi epsilon naught 4ar. We are going to add this and this, 4ar divided by r squared minus a squared whole squared, and it is along the p vector. This is the electric field at point P at the axial point. Now, if you are writing R is far greater than A, which means that point P is really far from the dipole, then we are just going to neglect this here, okay, and then we can write electric field E vector equals Q divided by 4 pi epsilon naught 4ar, and we have here r squared minus a squared. A squared we are going to neglect it, so it will become r squared whole squared. So it will become r power 4. So once again, if you see here, 1r will go away. This will become r cube. Now, dipole moment vector is defined as, P equals Q into 2a unit vector, like this. So Q into 2a is P vector. So we can write electric field as Q into 2a is dipole moment vector. So we are going to write 2 times P vector divided by 4 pi epsilon naught r cube. This is when r is far greater than a. That's all. Thank you.